Ever wonder how Amazon does their thing of you search everything on Amazon and you get every product related to it. But how? How exactly does that happen? And how exactly does Amazon know that you are looking for a soap or you are looking for, what do you say? Let's say a shirt, for example, or a mic. How does Amazon do its thing when you search on it and give you exactly what you need? In today's video, we are going to build a similar thing to that. We are going to build a recommendation system based on your search queries. It will be a search system, to be honest, but it will also act as a what do you say recommendation system, because it will be working with the keywords and it will extract the keywords from the listed products and etc from the database, let's say in our case CSV file. Okay, so without further ado, let's get into it. This project will be helpful for you to just know the basics of natural language processing as well as how recommendation system or search engines work. So yeah, let's get into it.
Okay, so moving on to our project, as you can see in this file system, as you can see, the Amazon products.csv is there, which contains these four things: the ID, the title, the description, as well as the category of the product. So now what we'll be building is kind of a search engine, which will take your query that you have searched. It will match that search with the product, like the title of that product, and it will list down all the products that it found a match with. Okay, sounds good? Yeah. So yeah, let's get into it. First of all, what we will require is some libraries to work with the data. As you can see, we have a CSV data, so obviously we will need pandas, numpy. So yeah, let's import that. So import numpy as np. And by the way, we will be deploying this project as a Streamlit app. We will be building a Streamlit app with this. It will be a short 5-line code or maybe 10-line code for the Streamlit app. But anyways, let's get into it. Okay. I'm sorry. Okay. So now first what we will do is import the necessary libraries. I'll just give a comment here. So import the libraries. Okay. So before anything, I assure you that you will be gaining some knowledge from this. Either it will be a Streamlit knowledge, or either it will be a NLTK, or based on stemming. Obviously, we will be using stemming, and yeah, you will be like gaining some knowledge on how to do natural language processing in machine learning. So yeah, I'm very excited for the project. I hope you are also. Okay, so let's start by importing the necessary libraries. So import numpy as np, and after that we will import pandas as pd. Then we will import the most necessary library that we require for this project, that is NLTK. What NLTK does is it allows us to use some features that are required for processing of the natural language, like English in our case, for the title, categories, as well as the description of the project. Okay, so we will import NLTK directly. Okay, and then we will import the stemming libraries. We will import snowball stemmer in this case, as well as we will import the TF-IDF vectorizer to vectorize our headings that will allow us to search for the project, that will allow the model to search for the project. Yeah, so let's get it. I'm sorry. Okay, so yeah, so let's import the snowball stemmer. So from, we'll do nltk dot stem dot snowball. We will import the snowball stemmer. Okay, then we will import the feature extraction libraries TF-IDF vectorizer to vectorize our headings. So from sklearn, that is scikit-learn dot metric, sorry, it's feature extraction, and then feature, the feature extraction dot in from the text file, we will import the TF-IDF, not the transformer, but vectorize indeed. Okay, so then we will import the cosine similarity function, like the cosine similarity to like match our products using like their keywords. I hope you get my point. Okay, so let's import the, what do I say, cosine similarity. So from sklearn dot matrix dot pairwise, we will import the cosine similarity. Yep. Okay, and now lastly for the streamlit app, we will require streamlit as st, and we will also, like, you can use pil, but in this case we are not using any image. So yeah, to make your streamlit app look beautiful, you can use pil. So from that you should import the image to, like, give an image to make it look cool, the streamlit app, I mean. Okay, enough of that. The importing libraries are done. This will be required, all of these will be required for this project. And then let's now load the dataset. Load the dataset. As you can see here, the dataset's name is Amazon products.csv, which contains ID, title, description, and category. So let's load it. So let's say data equals pd dot read csv, and what we will do is Amazon underscore products, yep, dot csv. Okay, I'm sorry. Okay, so after importing the dataset, we will like remove the unnecessary column that are not required for our model. So you don't require that ID, what is it, the ID column for this recommendation system to work, although it will be shown to your streamlit app, but while searching you don't need it. So yep, we will just remove it. So let's give a comment as remove unnecessary, I hope I'm spelling it right. Yeah, unnecessary columns, and let's do data equals data dot drop, and we will do id, we will do axis equals 1. What axis equals 1 does is it drops the column. The 0th axis is the row and first axis is the column. So I hope you get my point. Let's define a vectorizer, let's say not a vectorizer, a tokenizer and a stemmer. So what they will be doing is they will be helping us for like categorize, like doing the, what do you say, converting the text into the numerical vectors. So it will be more beneficial to the computers to work with the vectors in terms of like numbers instead of working with the text. Okay, every computer works with numbers. I hope you might know that. So for that you should convert your text into the, what do you say, the numerical vectors. Okay, so let's do a stemmer. First of all, let's give a name as stemmer equals to, and we will call the snowball stemmer for English language. Whoops. Okay. Okay, so this snowball stemmer will be working with the English language specifically, and yeah, let's define a function to like what do you say, return the stems. Okay, to, let's say, calculate stems. Okay, so let's do def, let's tokenize and stem the text that it receives. Okay, sorry, I'm not feeling well. So we will extract the tokens like using nltk.word tokenize function. So what we will do is nltk.word underscore tokenize, and now what you should be doing is text dot lowercase. Why this? Why lower? Or you can do upper actually, but some people have the just to like search first word as capital, or in other case some people might not do capitalization in every way, but it's okay. It depends on the person. uh, what I'm trying to say is every person has their own way of searching on search engine. So our search engine should be like adaptable to every way of a person typing. So for that, we will just convert all the texts into lowercase, and it will help our search engine to tokenize well. Okay. So after tokens, what we will do is stems. We will do stems, and we will do some list comprehension. That is with stemmer dot stem of t. Let's say token. Let's say token for token in tokens. Okay, so that's a small stemming, like with using some list comprehension, and lastly we'll just simply return the, sorry my spelling. Okay, we'll lastly simply return the stems. I hope you got my point. Okay, so now what we will do is create a tokens column, like a stem tokens column. So in the data CSV itself, so data of stemmed tokens should be equal to data dot apply. I'll just use the apply function, and I'll use the lambda function for this. For every row in tokenize, not mocanize, but tokenize stem, okay, with the row of, what is that, title? I guess it is title. With, I know, where did it go? Okay. Yeah, with a T capital. So if I close this and come here, and a T capital, that should do it. Okay. And now what we will do is, what is it? Yeah, plus, no, not here. We do plus. Okay. After doing a space, what we will do is a row or OW of description. I hope I'm spelling it right. Okay. And with the access one. So access of 1, that should be like after this. So access equals 1. Okay. So after this, what we will do is define the TF-IDF vectorizer. Okay. So after that, what we will do is define the TF-IDF vectorizer. What the TF-IDF vectorizer will do, it will vectorize our tokens that are getting stemmed using the tokenized stem function. Okay, so we'll define the TF-IDF vectorizer. I'll just come down here. Define the TF-IDF vectorizer. Okay, so then let's do TF-IDF equals to TF-IDF vectorizer, and what we will do is tokenizer equals to the tokenize stem function. Okay, now we will define a function. For what? We will define a function to find the cosine similarity. So let's do cosine similarity, and what we will do is give it text 1 and text 2. We are finding similarities, so we need two things: the first text and the second text. First text we will be concatenated with the like, what do you say, a space. So I'll show you how. Okay, firstly what we will do is text 1 and then concatenated equals to, we will do space, then dot join, and we will do text 1. Okay, similarly what we will do is text 2. Okay, so we are concatenating the text 1 and text 2 with a space, and after that what we are doing is we will create a TF-IDF matrix of using the vectorizer with the text 1 dot concatenated and text 2 concatenated. Okay, so what we will do is, firstly let's go and create the TF-IDF matrix, which will be TF-IDF vectorizer. What was the name? Yeah, TF-IDF vectorizer, and dot fit transform, and what we will transform it with is an array of text 1 concatenated and text 2 concatenated. Okay, after that what we will do is return the cosine similarity of TF-IDF matrix, and it's for 0th row and first column. Okay, so after that, after this function is done, what we will do is we will again define a function to like search the products, and it will be taking the query that you have provided to the stream data. Okay, so firstly what we'll do is def search products. Let's define a function and let's give it a query. Okay, after that what we will do is we will stem the query, and we will call the, what do you say, cosine similarity functions and all, and lastly it will be returning the results. Okay, so what we will do is after getting the query, we will firstly stem it. So query stemmed equals to tokenize and stem, as I know tokenize stem, and we will pass it the query. Okay, then we will do data, and we will make a column as similarity. I hope I'm spelling it right. Okay, so data, and we will do stemmed tokens dot apply, and what we will apply, a lambda function for x in cosine similarity of query stemmed and the x. Okay, not the cosine but cosine similarity of this function. Where did it go? This cosine similarity function will be applying, and it will take the query stemmed as well as the x. Okay, so it will compare this stemmed query with everything that is in the stem tokens column using this cosine similarity function, and whatever it finds similar to that query that you have provided, it will just return. Okay, I hope you got my point. So let's do a result column. Okay, not the column but a like, what do you say, a variable. So results equals to data, and let's sort them based on the like title, description, etc, etc. Okay, so let's do data dot sort values. So it will sort them based on the amount of similarity it has. So the most similar will be on top and the less similar will be on the bottom. I hope you. So for that we'll be using this similarity column. So after doing sort values, we'll call the function, then do by equals to what? We are doing it with the similarity column, right? So similarity column, and then ascending, sorry, equals to false. Not false, but false. Okay. Why? Because we need it in the descending column. For example, I type, what is it? Let's say I type HP laptop. It should not give me a Lenovo laptop. It should give me a laptop, sorry, the product which contain those two words first, then the Lenovo laptops. Because the laptop query is also there in the Lenovo laptops product listing, but I need specifically the HP laptop. So that's why it will be on the top. So we will be sorting them in the descending order rather than ascending order. That's why the ascending is equals to false here. And then we will do dot head. We will do the first, let's say 10 products. And what we will show is the title as well as the description as well as the category. I hope I spelled them right. Obviously I didn't. The categories should be, yeah, like that. I hope I have done everything correctly. Yep, seems to me it is good. So yeah, after that what we'll do is return the results. Okay, now what we will be doing is making a simple web app. That web app will take a title, your query, the query box will be given here, the text input I mean, and a submit button on which it will give you the result. Okay, so we will do st.title. Okay, let me give the comment. So let's say web app. It will also only take 5 to 6 lines, obviously. Okay, so st.title, let's say, and let's do title of the app, search engine, and product recommendation system on Amazon. Okay, seems a good title. And let's do a query box. So query equals to st.text input, and what we will do is enter product name, then we will do a submit button. Submit equals to st.button. We will provide it a query as search. Okay, and yeah, that's it. And on submit we will do a result. So we will call this function search products and it will show us the result. So for that what we will do is if submit So on submission, what we'll do is we will collect the results into this res variable. So search products, and we will pass it the query that you have provided. Okay. And lastly, we will do st dot write. We will write that result. I hope you got my point. And for this app, that's all you need. Okay. So after this, what we have done till now is we have constructed all of the app that we need right now. Now, what we will do is run the app. So I want you to go to your terminal, the new terminal, and also keep in mind that you need all these libraries installed. First of all, the NLTK, as well as scikit-learn, Streamlit, NumPy, Pandas, etc. Okay, so what we will do is, actually you don't need NumPy. I thought I would need, but still I didn't need that. Okay, so now what we will do is run the app. To run the app, we need a new terminal. After creating a new terminal, what we will do is run some queries as streamlit run. Obviously, it will not work because you need to provide your file's name. Okay. So first of all, what we will do is check if Streamlit is correctly installed. So why did I run Streamlit run? Because if you see a command not found or something like that, just reinstall Streamlit using pip. You can install it using pip install Streamlit and it will get installed. Okay, so now I'll just run the app Streamlit run app.py, and yeah, as you can see, the app is running, as you can see here. Okay, I did work tokenize. I'm sorry, the OBS got. So the good thing about Streamlit is I don't have to like redo everything. If I just save it and go here and say rerun, it will again get rerun. And as you can see, enter product name. If we search for soap, let's say, I hope there are columns with soap. Okay, the function is something. Okay, it is having some issues. TF-IDF matrix, cosine similarity. What happened? Row index out of range. Okay, fine by me. What I'll just do is, let me check. Says row index out of range. Okay, got it. If I do Control X and then do Control V, it should work in cases. Okay, soap. If I now search, no, it doesn't. Okay, raise key error. Okay, this is something that I don't know what happened to. I think the column names are not. The column names should be title, description, category, C, again do C. What? Control V, and then again value category and Control V, and save and rerun. It should work. And I think the app got. Let's stop the app and rerun. I think it should work now. If I do soap, search again, no. Key error, why so? Having issues. Key error, title, description, category. Okay, wait, I'll fix this and I'll come back. Okay, so what I did was something very unprofessional, but yeah, this was list. This here was another list. So if I do that and again rerun the file and search, it should get rid of it. Okay, so I'm sorry for what happened. So as you can see, we have typed soap and it has given us a result for this healthy soap, soap here, as well as soap here, then soap, and you know there are two soaps in this file. Yeah, I guess there are two, here first and here second. That's why it is on the top, because the cosine similarity is better for that compared to this one and this one, as well as these ones. And you know, here there is no soap, still there are some errors obviously. So yeah, I hope that is it for this app. So if you did enjoy this video, please hit that like button, subscribe to the channel, and I'll be making sure I bring you more of such videos. And yeah, this is Athurva from Pi Analytics, and I'll see you in the next one. Bye bye.